Uh, Let us start the discussion. Let the students join. So what we have, the dimension of the first test pieces as given in the following here. What is going on? Say we have this what you say prism shaped block which has cross section area around 1 centimeter each, and for isot there is a notch here as 28.28 millimeter at one end, and the length is 75 millimeter. Total length is 75 millimeter, and 10 millimeter square is the cross section area, and the notch is 28 millimeter away from one end. This is for isot. It is not at the center itself. For Chappie, notch is center at the center as 27.5 centimeter. Otherwise, the dimension is 55 centimeter in length. What the child was 75 millimeter. It is 2 centimeter less than the Chappie itself, and the notch is at the center, the 28.7, and its cross section is also same for both of them. So for isot, the cross section area of the sample SVC is same, that is 10 square, and for length for isot was 75 millimeter, and for Chatpi it is 55 millimeter. So length is for Chatpi material is comparatively less, where for isot is comparatively comparatively higher by 2 centimeter, and the notch is at the central portion of the Charpi workpiece, and for isot workpiece it is away from the center. It is away from the center. It is around 28 millimeter away from one of the end itself. You know the sensors are provided on to the workpiece to make it comparatively weak, so that it can have this. Uh, it can easily break by comparatively less punching weight in the machine during the machine operation itself. And the strikers, we call it, either actually this workpiece is being struck by not directly by the punch itself, but by a block fixed over the swinging punch itself. This block is different in shape, although their whole position for fixing the bolts are same, but the shape of the block is a bit different. For either this is at end it is fixed and it is conical like this, and rest of the portion is straight. And for HRP, the portion is flat, to which is facing the punch itself. Actually, which is facing the workpiece itself. You see, for riser, the notch is supposed to be the facing the punch itself, but at Charpy, the notch is just opposite side of the punch itself. That's why for Charpy, the end is flat, and absurd for riser, the end is comparatively sharp in shape, which is supposed to be strike directly to the material itself. The positioning I've shown you here between for the visor, this is the anvil itself, and the specimen is fixed vertically here by means of screw and bolt itself, and it is above the machine itself. It is above the anvil by an amount up to the notch, which means 27 millimeter away from this end itself. But Sharpie, it is placed horizontal anvil with the groupement in the center punch facing the opposite side of the striking face itself. So let us open up one of the page and go through the problem again. Again, I am showing you the machine itself. You see that machine has a vertical column like this here. This is the vertical column shown here and here, this side, which is strong enough so that it will transmit actually and this is strong base is there inside the machine. This is the strong base which is fixed at the four corner by means of bolts to the front directly towards the foundation itself. And in front of it, this this is the punch shown here for the uh, Sharpie impact test. Here the small impact side will directly hit to the material itself, which is at the opposite side itself, and notch is on the opposite side of the workpiece. Now this base is strong enough and this column is strong enough to absorb this type of heavy load, which is transmitted to it through the workpiece, through the anvil of the workpiece itself. Here we have the punch itself is the operating lever, which when we release, the will let the either start swinging, let the punch swing and strike the workpiece itself. And this is the full function, full form of the punch itself, which is at the where weight is at the bottom and the swinging handle is in the top itself. And with the bottom, we are fixing one of the we have the striking punches one after another. This is the load actuating handle. If you move it this in this direction, it will just shift one of the shaft inside, which is holding the punch itself, and shaft will go inside and punch will release and it will start in swinging towards the workpiece itself. This is the position. There is a shaft here, and it is supported with the bearing. And this for the vertical portion of the operating handle of the test piece is kept inside and holding this vertical here. Operating lever of the chap is shown here in the top. This is for IZ. Here, what you see here, there is a plate which is fixed on four corners by means of the four bolts, and which is holding the holding shaft of the IZ testing machine, and there is a portion of the movable portion of movable rod inside the holding punch is just shown here, which is being operated by that actuator handle. If you and it is loaded by string, and you remove this, you move the handle part of the right part, it will move this operating handle to inside the holding rod, and thus releasing the total punch itself. This is the process of releasing or holding and releasing the punch itself. In this side, what we show, it is the operating lever of the actuating punch is a operating lever of the uh, indicating punch itself, indicating rod itself, indicator rod itself, which is at always moves at par with the which is always parallel uh, with the lever for lever holding the load itself. This is the lever here, and this is always parallel to the lever itself, and lever will swing from front and back, but front and back of the machine. But lever this can swing only on the front, and it will hold there up to the height where the lever will move, and then lever may go down, but it will remain same in the same position itself. This is the uh, graduated scale over which two graduations is fixed, given. One is the graduation for the ISER, one of these is the graduation for CHARPI. The graduations, both the graduations starting from 0, and for ISER it is finishing at, for the ISER it is finishing at 85 degree, 85 to 90 degree, and for the CHARPI it is finishing at 140 degrees, 40 degree, which means with the swing of the punch itself, along with the striker hand bill, it will strike the workpiece, break it, and move up to the position, up to a certain position, and then again move back. And the length of the position last achieved by this punch itself, indicated by the indicator itself, and from the 0 of the scale is given by the uh, impact testing machine itself, impact testing rod energy. Next, because if there is no workpiece kept on the handle itself, and you release the operating handle or the swinging lever, swinging pendulum, then the pendulum will swing by the same amount, 85 on the opposite side, and go back to the original. Thus it will remain, go on swinging it from 85 to 85 degree, or from 0 to 85 here over the punch itself, unless you are stopped it by means of the brake itself. Same is the case of CHARPI. If the operating pendulum is reduced, it will move from 0 to 135 in the machine itself, when there is no workpiece inside to stop it, and it will go on swinging until you stop it by means of the holding brake itself. But if the workpiece is placed in between that passage, it will break the workpiece and lift up to a certain position, up to a fine position, and then go back. The last position, which is lifted, which is indicated by this operating lever itself, will give you the energy required for breaking the punch itself. This is the applicable for both ISO and CHARPI machine itself. Actually, it's graduated from 0 to 10, 10 degree or 10 joules, and intermediate is graduated by 5 degrees. So one of each degree is given by equal to 2 kilojoules. So if you have to, your value of the energy required for punching is directly applicable. It can directly calculated from the machine itself, because if say it goes to that up to 10, means 10 joules is required to say it is went up to 30. So from 0 to 30, it is went up to less than 30, only two graduation or two graduation less than 30, but because it takes 26 kilojoules to make the punch, ensure the punch itself. And so 20 plus 3 graduated line, 3 lines are there, 3 each is equal to 2 joules, with 26 plus 3 into 2 is equal to 6 joules, 26 joules. This is the required impact energy of the work itself. Which is shown, what I am showing here is 150, and this is equal to 160. This is around 164. Means 82, it is graduated as if twice per joule. So it is swinging around 85, 82 degree from both sides itself. And if you allow it to swing, it will start swing from here. Here initially you have to put the indicator punch here, and indicator punch will stay here. And if we indicator actuating punch lever will strike the indicator punch and move it up to the certain position, but it will remain straight. Up to that extent, the lever is moving up. This pendulum is moving up, and from 0 to that position will give you the expected energy required for making the impact load itself. Thus, I am fixing the indicator arm up to 160 for 162 for isolated impact test. This is the position of the lever. This is the holding lever which is moving up by just projecting from the top of this big rod itself. It will move inside if you operated by the operating lever, and this will carry the punch over its top. There is a place of fixing the lever over there. If you move the lever here, the punch will release and you will start, the pendulum will start swinging. This is one of the punch that is for the chat impact test itself. Shall I show you the anvil 1 second to make your matter clear to you? It's the position of chart test on 136 millimeter from the vertical itself. Again, I'm setting it to 144 degree. This is the position of the hand wheel itself. You see there is a fixed block here where there are two positions. Here is the position for holding the izer. Izer will place vertically here, and through this plate and through this headboard, it will fix it here. And but Charpi will be placed horizontally, and its punch will be opposite side of the izer testing for of the punch itself. And this is the block position which is fixed over the machine bed itself. And what this fixing block, this main anvil is fixed here like this by bolt, so that it can absorb the whole huge load of impact created by the punch itself. I avoided the punch, started swinging and broke the workpiece, and it reached around 120 millimeter or so, which will give us the play itself. What is there? Let us finish this work by going through another portion of this work itself. That's the impact testing machine. It is another handout we received from some other universities. Let us see how, if there is any important questions or answer from it. There is an impact testing machine, either test specimen of mild steel, aluminium, vernier calipers, specimen fixed in fixture. Here we are using the machine, all right, either test specimen of mild steel, there is the aluminium block, vernier calipers for fixing the size of the what test piece itself, and specimen fixed in fixture. In manufacturing locomotive wheels, coils, connecting rods, etc., the components are subjected to impact, shock, loads. These loads are applied suddenly. The stress induced in these components are maybe more than the stress produced by gradual loading. Therefore, the impact tests are performed to assess the shock absorbing capacity of the material subjected to suddenly applied load. These capabilities are exposed as rupture energy and modulus of rupture and notch impact energy itself. Two types of notch impacts are given commonly. One is isert, and this Sharpie, and another is isert. In isert test, the specimen is placed on as cantilever beam, means it is placed once fixed is one side and other side is totally hemming and top. It is like a cantilever beam itself. Specimens may have a V-shaped notch of 45 degree. U-shaped notch is also common. The notch is located on a tensor side on tensor of the specimen during impact loading. Depth of the notch gradually taken as T by 5 to T by 3, where T is the thickness of the specimen itself. The specification of the machine is the impact capacity will be 164 kilojoule. 164 joules is the maximum impact capacity. Least count of the capital G is 2 joules. Weight of striking hammer is 18.7 kg. Swinging diameter of the hammer is 1600 millimeter or 1.5 meter. This is longer than us. Angle of the hammer before striking is 90 degree or 85 degree hour cases. Distance between the supports is 40 millimeter itself. Striking velocity of the hammer is 5.6 meter per second, which is unknown to me. Specific size, specimen size 75 to 10 into 10. Type of the notch V into notch. Type of the angle 45 degree, and depth of the notch is 2 millimeter itself. Now procedure: lift the hammer to an approximate knife edge position and notch the energy stored in the hammer. For the standard ISO test, the energy stored should be 164 J. Locate the test specimen on the machine support itself. Release the hammer will break the piece and shoot up the other side of the specimen. Note the residual energy indicated on the scale by the hammer itself. Impact strength of the specimen of the is the difference between the original energy stored in the level and residual energy itself. Though initial energy, the residual energy and absorbed energy is given in this chart itself. Cautions: the modulus of rupture divided by effective volume of the specimen. Rupture divided by effective volume of the specimen. Notch specimen length, absorbed energy multiplied by effective cross-sectional area. What should be the precaution? The specimen should be prepared in proper dimension. Take reading more frequently. Make the loose pointer in contact with the fixed pointer, and after setting the pendulum, do not stand in front of swinging hammer. Place the specimen in proper position itself. Impact strength will be given by so many joules per square millimeter. Conclusion is that, say, what is the vital question? In what way the values of impact energy will be influenced if the impact tests are conducted in two specimens, one having smoother surface and another having scratches on the surface itself. The value will not be different, much different, because doesn't depends on the surface finish of the specimen itself, but depends on the size and cross section area of the specimen itself. What is the effect of temperature on the values of rupture energy and notch impact energy? There is no such direct effect of temperature visible for this type of machine. In the same specimen can be used, will give you the same results in summer and in winter. What is resilient? Why it is different from proof resilience and toughness? What is the necessity of making a resilience means what is the amount of resistance it can offer? It is how much you could given with the proof stress of the machine itself and how much is the toughness and toughness is the there. What is the necessity of making a notch in impact test? We are not to break the notch, and we are making the specimen a bit weak so that it will strike and break in one particular one single blow. If the sharpness of V notch is more in one specimen than the other, what will be the effect of the test result? Generally, V notch should be the same. Otherwise, the set specimen which has bigger notch is comparatively become comparatively weak, and they may give you certain different result, which is not desirable at all. Okay, next. Start share. So we are finishing this particular work here as our strength of material lab here in isolated impact testing machine. We are using the pendulum impact testing machine of 30 kg meter swinging capacity. Thank you.